Let's talk about atoms.
We're going to talk about me?
No, not you. Atoms. And how are they held together?
Okay, let's talk about the stability then.
Well, atom stability is determined by two forces, the electrostatic force and the strong nuclear force.
Looking at this graph behind us, we see that there is a curve, and as this curve increases with energy, at some point it goes down. What could potentially be going on right here?
Well, atoms are made of little tiny pieces called nucleons. So as we add on the nucleons, the strong force gets stronger, which wants to hold the atom together. When you look at the graph, you see iron 56 is the top of the chart. It's the most stable nucleus. It's small enough that the strong force holds it together really tight, but it doesn't have so many protons that the electrostatic force wants to rip it apart.
When you do increase the amount of protons, they are like charges, and that explains why Coulomb's propulsion takes into effect and overrides the strong nuclear force.
This happens because the strong force is so short range that when the atoms get too big from having too many particles, where the atoms break apart.
Well, couldn't we just add neutrons to make them more stable?
Not really, because even though it would increase the strong force, it also makes it bigger. Since the strong force needs a very short range, making it bigger doesn't always make the strong force stronger.
Okay, so that makes sense for radioactive decay. Beta decay would be when we would turn excess neutrons into protons, or excess protons into neutrons. That is to fill the more probable energy states. And for an element's last surviving flight, they're going to actually shoot out a helium nucleus, and we can call that alpha decay.